going? Okay, so today we're going to talk about how you can solve systems of equations using inverse matrices. So yesterday we talked about the determinant and Cramer's rule, and we used GeoGebra to find the determinant that way. We're going to learn another way to solve a system of equations. And so in order to solve systems of equations, we need to learn about something known as the identity matrix and the inverse matrix. So an identity matrix is a square matrix that, when multiplied by matrix A, equals matrix A. So basically, when you think about that, if I take matrix A times the identity, I get A. If I take the identity times matrix A, I get matrix A. So if I think about that, what really does the identity matrix resemble? It resembles something that we use when we multiply. And what is that? What?
Community property?
Okay, kind of like that. It's multiplying by the number what? 1. Okay, so pretty much this is like multiplying by the number 1. And so if you notice, here is the identity matrix. It's a 2 by 2. Here's the identity matrix for a 3 by 3. So what do you notice about the identity matrix? What are some of its characteristics?
All the ones are diagonal.
All the ones are diagonal, and then everything else is zeros. Good. So you just have ones along the diagonal, everything else is zeros. So if you wanted a 4 by 4 identity matrix, it would have ones just all on the main diagonal, and everything else would be 0. Okay. So now we're going to talk about inverse matrices, and inverse matrices are something that we're going to be dealing with a lot today. So two matrices are inverses of each other if their product is the identity matrix. Two matrices are inverses of each other if their product is the identity matrix. Now, one of the things you need to understand if you notice there are two equations below, notice multiplying by the inverse on both the right and the left of A. That does make a difference. Okay? So matrices do not hold the commutative property. Matrices do not abide by the commutative property. So it does matter where you multiply, if you multiply on both the left or the right. And we've discussed that in some of our other problems. And so now what we're going to do is we're going to look at how we can determine if two matrices are inverses of each other. So if these two matrices are inverses of each other, all I'm going to do is take A times B, and then I'm going to take B times A. So what I want you to do, I want this half of the room here, okay, this group of 4, I want you to take A times B. I want this middle group to take B times A. So remember how you do that? So A times B, you're going to go ahead and take row 1 times column 1. Okay? What you're going to do for B times A is you're going to take 1/4, 1/2, -1/2, -1. Here's your B times A. This is what you're going to need to do because it is different. So those of you that have the B times the A, here's your row 1 times column 1. So those of you that have A times B, you can go ahead and use what I did. Those of you that have B times A, remember what you're going to do is you're going to take first times first plus second times second. So first of all, A times B, when you do that, you're going to get -4 times 1/4, which is -1, plus 2 times 1/2, which is 1. And what does that come out to be? -1 plus 1? 0. Okay. So then now what you're going to do for those of you on AB is you're going to do this one. So what is that bottom part for? The bottom part is what they're going to do. They're doing B times A, you're going to do A times B. So instead of everybody having to do everything, so this is B times A This is A times B. So you got all zeros, and that was B times A. Same with you, Jordan, did you get all zeros? Okay. One half plus negative one half.
Yeah.
So you got all? Up here, what'd you count? 2 plus negative 2. 0. What did you guys come up with for the next one? When you multiply these, A times B, you got 0, 0, 0, 0. B times A, you got 0, 0, 0, 0. Are those inverses of each other? Are those inverses of each other? No. Why not? There's no ones. In order for them to be inverses, you would have had to have gotten this. And you didn't. Yes, you do need to check both ways. So what you're going to have to do is you're going to have to multiply A times B and then B times A on these problems. All right, let's determine this one. Okay, so A times B. I'll kind of get you going because it seems like maybe you need a little bit of a boost there. So I'm going to take 3 times 3/4, which is 9/4. And then I'm going to add negative 5 times 1/4, which is negative 5/4. So 9/4 and negative 5/4
This
is,
math student beat him to it.
so 9/4 and negative 5/4 will be 4/4, which is 1. So then now A times B, you're going to do row 1 times column 2.
Are they always
So
gonna be fractions?
Not always. Generally, I will tell you this much though. You're going to find out that a function and its inverse, one of them will probably have fractions. It's very rare that you can have two matrices that one of them won't have a fraction if they're inverses. So what's that one going to be? This one will be 15/8 plus, what's this one going to be? Negative 5 times 3 is negative 15/8. So your answer will be 0. So did anybody get anything yet? This one here, what'd you get? Get 0? 0. What'd you get on this one? Negative 10/8 plus 18/8, which will be 8/8, which is 1. What'd you guys get on the BA? You got it done yet? Okay. So BA. So that'd be negative 15/4 plus 30/8, which would be 0. Row 2, column 1, which would be 3/4, plus -6/8, which is 0, and then
Negative
5/4 and 8, which is 1. Okay, so they did in fact come out to be 1, 0, 0, 1 from both. So these are in fact inverses of each other. Yes?
Is there sometimes when it only comes out to be 1, 0, 0, 1 from one of those?
There might be. I right now, off the top of my head, can't think of one, but there might be.
Okay.
I mean, you do need to check both ways. I
That
do.
would not count as a inverse then?
No, has to be both. Okay. Alrighty, so now we're going to talk about how you find the inverse. Now this is a little bit weird, okay? But I'm going to teach you some tricks that might work, or that might help you remember this a little bit. So if A equals a 2x2 matrix, A, B, C, D, then the inverse of A equals 1 over AD minus BC, and then D, negative B, negative CA. And I'll let you go ahead and write that down, and then I'm going to teach you kind of a way that I remember what to do. Okay, as you're writing that down, I want you to think about where AD minus BC looks familiar. So, where does AD, A times D, minus B times C look familiar?
When we cross multiply.
Yeah, and what was that called?
I can't remember.
You're right, but what was that special word called? Starts with the D. Determinant. There you go. Good. And so basically, what you're doing is you're taking 1 divided by the determinant of A. Okay. But instead of writing 1 over the determinant of A, I think it's better to put AD minus BC. It helps you remember things. Notice AD minus BC can't be 0 because you would have division by 0, which is undefined. So if this is ever 0, boom, you can't find the inverse, and you're done. Now this next part kind of looks kind of jumbled. There are 2 things I want you to remember. I want you to remember switch spots, switch signs, okay? Switch spots, switch signs. Now let's see how that works. My first diagonal, AD, I'm going to switch spots. Notice on the first diagonal they flip. Okay, so on this diagonal, this is your switch spots. Notice how the spots were switched. On the next diagonal, you're going to switch signs. Notice how the signs are switched. Okay, switch spots, switch signs. Switch spots, switch signs. If you can remember that, this inverse is actually fairly easy then to do. Switch spots, switch signs. So let's go ahead and look at finding the inverse of 1. Okay, find the inverse. Notice if it exists. Because if my determinant is 0, it doesn't exist.
So you have to find a determinant first?
And that's what I'm going to divide over. So I'm going to find the inverse of 7, negative 5 to negative 1. So the very first thing, I'm going to 1 over AD. So AD will be 7 times negative 1 minus BC. So negative 5 times 2. All right, so let's do that real quick. 7 times negative 1, negative 7, minus, what's negative 5 times 2? Negative 10. So really, so am I going to get 0 there? No, so that means I need to go forward. So now we need to remember, switch spots, switch signs. So on my first diagonal, what does that become? Negative 1, 7. There's your switch spots. What do I do on the next diagonal? Switch signs. So that becomes, oops, instead of being a negative 5, what does that become? Positive 5. What does the 2 become? Negative 2. So switch spots, switch signs. Now what we need to do is actually calculate that. So in my fraction, I have 1 over what? 3. And so what I'm gonna do is I'm gonna take 1/3 times each of those individual terms, and now you're gonna see why you get fractions. Yeah, and so my inverse is actually going to be -1/3, 5/3, -2/3, 7/3. And you're gonna find a lot when you take the inverse, you are gonna get some fractions, and they might be some really funky fractions. And that doesn't mean you've done it wrong. So you need to remember, switch spots, switch signs.
So is that your answer?
That is your answer, and we're done. So it's really not overly that difficult if you can remember the little trick. So, oops, let's go back. Evidently it skipped. Let's go back to 1. There we go. Did I go back all the way 1 there? Okay.
Did you want? Oh,
There we go.
7 minus 1.
Did I still skip 1 there?
-2.
Okay. So here we go.
3.
I want you to go ahead and try this one for me. So 1/AD minus BC is your very first thing that you're going to do. And then switch spots, switch signs.
Jeez. You get the- you get your volume.
What you're doing? So what'd you get? You got the determinant to be what?
0.
0, because when you do the 1/, oops, let me do purple. When you do the 1/, -8 times 9 minus -6 times 12, you're actually going to get -72 plus 72, which is 0. So this is what you answer. No inverse exists. And you're done. You don't have to do any more. That's why it's important to find your determinant first instead of going through all the process of writing everything and going from there. All right, let's look at another one. There we go. 2, 1, -4, 3. 2, 1, -4, 3. Find the inverse if it exists. So as you work through this problem, I'm going to put steps up every so often.
Do we reduce the bracket?
Yes, you do. You already got it? Wow. Okay, there's what I got. Compare with what you got. Now real quick again, did everybody get 10 for the determinant? Okay, so then the other spot is just making sure, did you switch spots correctly? Did you switch signs? Okay, so remember on that first diagonal here, I'm going to switch spots. And then on the second diagonal here, I'm just going to switch signs. Okay, so your inverse should be 3/10, -1/10, 4/10, 2/10. Any questions? Yes, ma'am?
Do we need to reduce the fraction?
Oh, yes, 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 I'm sorry. So some of you probably had 2/5 and 1/5. Is that what you had? Yep, I'm sorry. 2/5 and 1/5. So you do need to reduce those down. Yes, good call. So really, not too bad. All right, the very last thing we're going to discuss, okay, is solving this matrix equation. The reason why we're going to do this is we're going to go ahead and finish the section today, and then tomorrow I'll give you some time to work. All right, so it says solve the matrix equation for x. Now, what we're going to do right now is we're going to look at this on a lot more scaled back version. What you're going to probably see is you're going to see something like this instead. Something like that, okay? But instead of looking at something like that first, I'm going to go ahead and look at something like what I've got so that I learn a little bit about how to solve these equations. Now notice what I have there. I have a times x equals b. So if I was going to solve that just in a normal equation for x, what would you do? Just in a normal equation. Like if I just had a times x equals b, before we even learned anything about matrices, what would you do to solve that for x? You would what? You would do what with the a? Divide. So basically, in a normal equation, this is what you would do, right? And then you would solve for x. We've got a problem, though, because matrices you can't divide. So instead of dividing, I'm going to do something that I just learned today, and I'm going to multiply by the inverse. Now, where I multiply by the inverse is pretty important. So if I want to get rid of this a, I have to multiply by the inverse of a right here on the left. So if I multiply it on the left side, I've also got to multiply it on the left on this side. So do you see how that works? So the inverse and a cancel out, and I'm left with x. On the right side, I've got a inverse times b. And it does matter what side you put them on. It could be the difference between being able to solve a problem and not being able to solve a problem. So let's look at the next one. X times b equals a. I need to get the x all by itself. So what do you have to do? Multiply by the inverse of b on what side? The right. So I'm going to multiply by the inverse of b here. If I multiply it on the right on this side, I have to multiply it on the right side. So my answer will be x equals what? A times b inverse. Good. The very last one, I kind of threw something in there. What do you think you're going to do on that one? You're going to add c to both sides. Good. So really, I end up having now bx equals a plus c. Ah, now what do you do? Inverse of what? On the what side? Left. Now, how you're going to do this with the existing a plus c's, you're just going to put parentheses. You can do that. So really, x equals b inverse times a plus c. Alrighty, so where are we going with this? Oh, just a second. This is where we're going with this. Okay, so right now, all we're going to do is we're not even going to solve this equation. I'm just going to go ahead and write this out. So this is how I'm going to write it out. And I want you to see if you understand where I got these numbers. Where did I get the 1? The x. Good. Where did I get the 2? The y. Where did I get the 3? The x. Where did I get the negative 6? The y. So see how I took those numbers? I put those into a matrix. Where did the x and the y come from? Yeah, those are the variables. That's how you write it in a column. Where did I get the 9 and the 3? On the equal to sign. So last but not least, oops, just a second. Last but not least, let's go here. How would I write that one? 4 negative 2,
6,
6, 9,
X,
xy,
Y.
22, negative 3, good. I'm actually gonna stop today with that. We're gonna solve those tomorrow, but I think you've kind of hit a limit. Okay, and so we're gonna come back and finish those last two. This assignment is gonna be everything, so you're not gonna be able to probably do those last few problems, but this assignment is everything, 13 through 25, 28 through 34, the evens. No, this is not due tomorrow, it's actually gonna be due when we come back from break. I will continue with those last two problems tomorrow, and then that'll be it.